Hello, I'm Todd Trobot. I'm an undergraduate student in mechanical engineering.
Hi, I'm Eric. I'm a graduate student in mechanical engineering.
Hi, I'm Robert. I'm an undergraduate student studying mechanical engineering.
Hi, I'm Evan. I'm an undergraduate student studying mechanical engineering.
Hi, I'm also Evan, and I'm a journalism student.
My name is Richard Gossetis, and I'm a mechanical engineering major.
Together, we are Crustacean.
All right, for the Invent for the Planet 2020 competition at NMSU, we set out to address the problem of microplastics in the Pacific Ocean. Using the natural processes of the ocean, we were able to automate a device we think can be deposited and it will collect the microplastics. At Crustacean, we are ending the cycle of single-use plastics. And though the nature of our efforts is conservation, we designed the system to collect microplastics with the intention of establishing a profitable business. For this video, it will give you an introduction to the issue, and it will also show you the 48 hours of research and development that we did.
What weighs more than 43,000 cars and is over 2 times the size of Texas? The largest garbage dump on Earth, the Great Pacific Garbage Patch. Also known as the Pacific Trash Vortex, this collection of ocean-faring garbage weighs more than 87,000 tons and consists of 1.8 trillion pieces of plastic.
Is all the single-use packaging. It's the straws, the bags, the bottles,
hurting animals. It's in our food chain.
All this
Plastic is everywhere.
Wants to throw away.
The Crustacean family of tools uses the natural processes of the ocean to travel and collect microplastics, which are the easiest materials to repurpose and pose the biggest threat to the ocean ecosystem. We designed this system to operate on the principles of sustainability, namely people, planet, and profit. The gyre itself is working for us by collecting the plastics, and the current operates our buoy and locker system. At Crustacean, we are doing more than recycling. We're ending the cycle of single-use plastics. Thank you.
So there's, as you might know, a growing concern over what's called the Great Pacific Trash Pile floating in the Pacific Ocean. A lot of the trash in this trash pile is microplastics, right? To clean them up is a big, complex, difficult, multifaceted issue. So what's our solution for properly collecting and disposing of ocean plastics? So for some background and motivation, you've got to know your enemy. The Great Pacific Garbage Patch is this large area of marine debris trapped in the North Pacific Gyre, a large current circulating. The vast majority of pieces of trash are microplastics on the size of less than 5 millimeters. Right? Much of this comes from larger pieces of plastic breaking down due to sunlight and erosion in the ocean. Specifically, the eastern garbage patch is located between Hawaii and California, and it has an estimated size of 1.6 million square kilometers, more than twice the size of Texas. It's estimated to have 80,000 metric tons and 1.8 trillion individual pieces, and it has a density estimated to range from between 110 kilograms per square kilometer of area. Don't think of it, however, as this big island that you can step on. It's this vast dispersed area that's more like a milky soup. Microplastics can pose a big health hazard to ocean wildlife, right? Microplastics floating on the surface can block sunlight to plankton and algae below, affecting the food web. Fish and sea turtles eat microplastics, mistaking them for food, and this just passes higher up the food chain to tuna, whales, sharks, and humans. Right? A big issue is that microplastics can also absorb toxic chemicals, which we don't want to end up inside of us.
So how do we clean up the ocean? It is a complex and multifaceted problem. We think we can resolve this problem by integrating existing technologies to implement what would be a waste management system, much like we have today. The trash bins that we have out in our yards, they get collected once a week after being filled up with trash. We want to do that for the ocean. Now, our system would be completely automated, require very little power, and would be completely autonomous. The way it would work would be a drone, ideally gets signaled by a filled trash bin connected magnetically to a buoy. After receiving the signal, the drone will transport an empty bin, attach it to the buoy, magnetize, detach, attach to the filled bin, come back, and transport this to Hawaii where the plastic would be processed. Again, this system would be completely automated, completely self-powered, not disturb marine life, and be profitable.
So at the beginning, we look at the floating sea beam trash collector all being made out there. We love the cashback design, so we can put the cashback filter in it to prevent microplastic going out. With that design, you use a pump to suck the water and the trash in and push the water back outside the ocean. However, with our design, we don't want to use a pump. We will use the sea motion pouring out into our bin with a spring to connect to generate the motion by itself, and the water will going out through the hole of our bins. We did a bit of flow simulation to see how our bin would react to the water. The water going, we can see positive results, the water going fast in the bin and then going out through the hole with high rate. After that, we 3D our printed model to do a bit of simulation in water. We physically use our hand to pull up and down the inner bin to generate the motion we're looking for, and we managed to catch some microplastic in there.
So our drone, which we have named Davy Jones, will be a solar-powered drone which launches from Hawaii and utilizing GPS trackers and homing beacons will travel out into the ocean to where our buoy is located, holding our bins, which we will call lockers, and it will grab onto this bin and bring it back towards Hawaii as previously stated. And we at Crustacean believe in our product, so all the plastic material that we collect can be used to create the hull of our drones as well as the rest of the components as needed.
Our sea bin collector will consist of 6 parts. Our estimated material cost right now is about $579.83. On the inside, we have a nylon 6 200 micron net. This net is water insoluble, is recyclable, and it will not release any harmful chemicals into the sea or onto the fish. This net is 200 microns because it is equivalent to 0.2 millimeters, and the majority of microplastics in the ocean is 0.3 millimeters or greater. That net will then go inside a nickel alloy 625 bin. This bin is saltwater resistant and it's very durable. This bin is estimated right now to hold 100 gallons of microplastics. And currently in the market, there is a huge demand for recyclable plastics. Major companies such as Adidas manufacture 40% of their products with recyclable plastics. We estimate that a full bin, 100-gallon load, will be equivalent to 30,000 shoes. Then on the outside of our metal bin, we have a high-density polyethylene bin. This bin is very durable, is buoyant, resistant to seawater, resistant to UV rays, and has a longevity of 50 to 100 years. Then between our plastic bin and our metal bin, we have a chrome silicone alloy steel spring. This spring is rated for 200 pounds per inch, and we believe that with a full load of water in the metal bin, it will compress the springs and have enough force to release the springs. So, can we propose our solution and can it be implemented? We believe that it can. The cost is relatively low. We estimate after manufacturing costs, our sea bin to be approximately $1,000. This is very low compared to our competitors who now run the market at $4,000. Is the proposed solution a technically sound solution? We believe yes it is, because it is no energy required, it is self-sustaining compared to our competitors who they require energy to run their sea bin. We do believe our product will work.
In conclusion, I believe our system consists 3-part has met all requirements and it will give us great profit, so we're hoping you will invest in our products.
At Crustacean, we are ending the cycle of single-use plastics.
Thank you.
Thank you.